In this video tutorial, we will see the interfacing of 4:4 keypad and a 16x2 LCD with LPC1768 ARM Cortex M3 microcontroller. Let us first understand the interfacing part. Here I have a 16x2 LCD wherein VSS it is connected to ground, VDD it is connected to 5 volts, and VEE it is connected to a 1K port. So basically with this you can control the brightness of this LCD. Then we have 3 control lines: RS, R/W and enable, and these are connected to port 0.9, 0.10 and 0.11. Now what is the role of RS? RS stands for register select. So in the LCD we have 2 types of registers. One is a command register and the other is a data register. Now what is a command? Command to the LCD, for example, let's say there was some data which was already printed on the LCD. Now I need to clear this screen. So I need to send a command to clear the screen. And the command for clearing the screen is 01H. Similarly, I want some data to be printed on line number 2. So in such a situation, I need to force the cursor to start from second line. So I need to send the command C0H. So these are the commands. Then what is the data? Data is that which is printed on this 16x2 LCD. Right? So whether I am sending the data or I am sending the command, I need to inform the LCD. And that information I am providing through this RS pin. If RS is equal to 0, then whatever I am sending through these data lines, it is the command. And if RS is equal to 1, then I will be sending the data. So that is the role of register select. Then comes the read-write signal. So read is to read from the LCD. Basically, we read whether LCD is busy or not, but we are not using this functionality here. Then the other option is we can write. So we are not reading here, but we are writing here. Okay. So in order to write, so this read/W bar should be equal to 0. Then you can write to the LCD. You can write a command or you can write even a data. The third signal is the enable signal. Now what is the role of this? So this signal will make sure whatever the command or the data which you have sent is written onto the LCD. So if you make enable high to low, then whatever the command or data which is sent via these port pins will be registered in the registers of the LCD. So the procedure for sending either the command or the data to the LCD is as below. First you will make enable high, then you will select whether you are sending a command or data, and anyway the read write will be 0. Then whatever you want to send, you will send through these data lines, then you will make enable equal to 0. So this is the functionality of these 3 signals, that is RS, read or write and enable. Now we have 4 more lines which are connected to D4, D5, D6 and D7. So these lines are connected to port 0.19, port 0.20, port 0.21, port 0.22. Now what is interesting here? D0 to D3, they are not connected. Why? Because we have a mode in LCD which is called as 4-bit mode. And this mode basically we use to reduce the number of IO pins. See, if I had connected D0 to D3, then I should have used 4 more pins of LPC1768. Hence, by using a 16x2 LCD in a 4-bit mode, I am actually reducing or I am saving 4 IO pins on LPC1768. So in this mode, how do we send the 8-bit data? We shall see that in the software logic. So this is all about the interfacing of a 16x2 LCD with LPC1768 microcontroller.